Okay, we're going to look at some problems to start to help us review for our circle tests. So this first problem says match the notation with the term that best describes it. So we have this figure below, over here, which got two circles. We have circle C, and we have circle G, and then all this other stuff. So if I want to look for the centers, there are basically two centers. There's center C here for this circle, and center G here for this circle. But since there's no G, C must be our center, so this is our center. Now a chord is really any segment that really goes from edge to edge of the circle. So there could be lots of chords. So if you think about segment AB, that would be a chord because it goes from edge to edge. Technically AD is a chord as well, but we also give that a special name because it goes through the center. So our chord really is AB. Now C, the diameter, is that special chord that goes through the center. We know that that segment AD is the diameter because it goes through the center and goes edge to edge. So the diameter is AD. Now radius is a segment that's going to go from the center to the edge. So there are actually lots of radii. CA would be a radius, CH would be a radius, CD would be a radius, GE would be a radius, and GF would be a radius. But if I look at all these, the only one that's really on our list is CD. So CD would be our radius. Okay, the next one is point of tangency. So if you remember, tangents means the line is only going to intersect the circle one time, and whatever that time is what's called the point of tangency. Typically perpendicular to the radius, so there is a point of tangency because it looks like HF is tangent. F would also be a tangent because it is touching only circle G at one point. But also we could say that D is a point of tangency. So all these really are points of tangency, but the only one that's on our list is D, so that would be our point of tangency. So now we have common external tangent and common internal tangent. Now an external tangent is a tangent that's going to touch two circles, but it doesn't go between them. So that would be this line down here, DE, because it touches both circles at only one point, but it's only on the outsides of the circles, doesn't cross between them. So the common external tangent would be DE. The common internal tangent is the tangent that crosses between the two circles, so that would be this guy. And it goes down in between these two circles. So that is HF, or FH, is our common. So our last one is the secant line. And the secant line is really just a line that's going to go through touch the circle twice, passing through it. So that would obviously be line AB, because that's the only choice left. But if we look at it, that line AB will cross through A and B in the circle. So H is our secant line, AB. Now it's interesting, AB was a chord and a secant, because the chord part that goes from edge to edge, AB, the segment, is a chord, but if you continue that, you get the secant line. Okay, for number 2, we're going to try to find the measures of the following angles and arcs based on this circle below. So it says find the following measures based on the diagram below. So the first one says MN, which is this one here, and then we're going to do NQP, so we're basically going to get a lot of them. Now you'll notice that these have these congruence marks, which means this angle is the same as this angle, so that's important. Now really we have two of the arcs of this circle, so really I can find what this arc is between M and P because I know all the circle arcs add up to 360. So if I take 360 minus the 100 I have, minus the 140 I have, I'll have 120. So between these two is 120. But since the central angle is the same, between angle MON and PON, if I wanted to find each arc, I could just divide them by 2 because they're even. So this arc is 60 and this arc is 60. So right away I know arc MN is 60 degrees. I also know this angle is 60 degrees because remember, the central angle, the angle that starts at the center, is the same as the measure of the arc. I know angle POQ would be 100 because it's the same as well. And I know angle MOQ would be 140. So if I added those central angles, they would also add up to 360 because they're the exact same as the corresponding arcs. So now let's find the different arcs we want. So NQP, so N and QP, so to go that order, I'm going all the way around, N to Q to P. So it's really everything except for the 60. So for arc NQP, it's really 360 minus only the 60, so it's 300. All right, so now let's look at the next one, which is arc QN. So I'll highlight this one. QN goes from Q to N. So if you look, the only arcs that make up QN are the 100 and the 60. So if I add those together, QN is simply 160. Okay, let's look at measure of arc PM. So we're going to measure of arc PM. That is just this arc right here, going from P to M. So that's just going to be the 60 plus 60. So those two together are 120. Okay, our last arc is arc NMQ. So if we go in order, N, and then M, and then Q would be this arc here. So really it would just be the arc 60 and the arc 140, and 60 and 140 is 200. So really the only thing I had to use was knowing that the central angle is the same as the arc measure and knowing that all the arcs in a circle have to add to 360 degrees. So 3 is problems where it's trying to determine if the following segments are tangent to the circle. Remember, they're tangent only if they make a 90-degree angle. And the easiest way to show if something makes a 90-degree angle is to see if the Pythagorean theorem holds. So in this first one, if I want to know if this is a 90, then I really want to know if a squared plus b squared equals c squared. So if I plug in those numbers, 6.6 squared plus 11.2 squared, we want to know, does this equal 13 squared? And we always put the biggest number as c, that's the hypotenuse, or the one across from the perspective 90-degree angle. So if I calculate that left side, I get 169. That's 6.6 squared plus 11.2 squared. And 13 squared is also 169. So what that tells us is basically angle A is a 90-degree angle. So in this case, we could say segment BA is tangent to the circle. Because if it intersects the radius at a 90, then we say it is tangent, meaning at only one point. So really the same thing for the next one. If we look at our triangle, we have a 12 side, we have an 8 side. This one has part of the side, but remember, this is a radius. So if this distance here is 8, this distance must be 8 as well. So if I pull this triangle to the side, this is 12, this is 8, and this would be 15, which is just that 8 and 7. So I'll see if Pythagorean theorem holds. Is 8 squared plus 12 squared equal to 15 squared? That is our question. So that's 64 plus 144. That is going to be 208. But the other side is 225 if you take 15 squared. So in this case, we say angle A is not 90 because the Pythagorean theorem is not holding. So we'd say BA is not tangent. Okay, let's look at a couple other questions. This says, if line AB is tangent to circle C, find the value of R. Now remember, we said if it's tangent, then it is going to be making a 90-degree angle. So since we have a 90-degree angle, we know we have Pythagorean theorem that applies. So again, the hypotenuse would be by itself, so r squared, which is one of the sides, plus 20 squared, which is one of the sides, must equal the hypotenuse squared. So r squared plus 400 equals 25 squared, which is 625. So now we're just really solving for r squared. I'll subtract 400 from both sides, which is going to give me 225. So R is 15. So again, if it's tangent, we know it has that 90, so we can use the Pythagorean theorem. Okay, let's look at question 5. If AB and AD are tangent to the circle C, find the value of x. Well, this goes back to one of those theorems we had that said if we have two tangents that intersect at a point outside the circle, which these do, then what that happens is it is going to make two equal segments. So the distance from A to B will be the same as A to B. So since we know these as variables, all we simply have to do is set those equal. So if we solve this, I would subtract 2x from both sides. So that would give me 3x minus 8 equals 7. Then I'll move the number by adding 8 to each side. So I'll get 3x equals 15, and I'll divide both sides by 3. So x is 5. So again, a really easy theorem. If you have two tangents that meet at an external point, we consider those to be equal. So the last two problems have to do with the equation of a circle. The first one says write the equation of a circle with a center of 1, -4 passing through the point 2, 4. Now remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared. So we know the center, now we just have to find the radius. Now the radius is really the distance from the center to any point, so we can simply use the distance formula to find that center. So if you remember what the distance formula is, it's x1 minus x2 squared plus y1 minus y2 squared. So if I find the distance between the center and the other point, it would be 1 minus 2 squared plus -4 minus 4 squared. So this would be -1 squared plus -8 squared So negative 1 squared is 1 plus 64. So the radius is the square root of 65. So this would be our radius. Because again, the distance between the center and any point on the circle is its radius. So now all I have to simply do is plug in my center, which would be x minus 1 squared, plus y minus a negative 4, which would be y plus 4, equals radius squared. So if I take the square root of 65 squared, I get 65. So this would be the equation of a circle with the center 1, negative 4, that also would have 2, 4 on its edge. Now this last one is probably even easier because we really can figure out what the center and the radius are just by looking. So if this is my center, looks to be negative 2 and 4. So that's my center. And then my radius in this case, I could just count. So this would be 2 units because it's going from negative 2 to 0. So to write my equation, real simple, I'll subtract x minus negative 2, which is x plus 2 squared, plus y minus 4 squared equals 2 squared, which is 4. So hopefully this first part of this review for our circle test was helpful. We will have another part that we'll do next time to help us get ready for our test.